welcome to another video. Okay, so this is the first video in the SQL playlist, and as usual, we will go through a good foundation first. So we'll be covering some basics of SQL, look at the theoretical parts we need to know. We need to understand database, understand SQL, how SQL is related to database, and why we should learn database as data analysts. Some important concepts or key things about database and about relational database itself, or SQL. Okay, I'm very excited. Okay, I don't know about you, but yes, you should be excited because you're gonna get so much value from this entire SQL playlist, beginning at the very foundation. Right, so this builds a solid ground upon which the practicals can sit comfortably on. So delve or dive into it together with me. Yes, as you can see, this is the outline, SQL basics, and we look at it, introduction to SQL. This is what we'll cover. Okay, so I'll just scroll slightly or gently, slowly, whichever one. Why you should learn, and why data analysts should learn SQL, types of databases, basic concepts in SQL, SQL language categories, the subcategories, the DDL, DML, and all, data type, constraints, relationship, that's the data model, cascading referential integrity, very important, normalization in database, right? Then some basic SQL operation. Then we look at the SQL best practices. Okay, so if you're excited, just leave a comment. If you've learned SQL before, leave a comment in the comment section. If this is your first time learning SQL, also drop a comment because you're about to have an exciting and amazing time with me. All right, let's delve into it. All right. Now, the very first thing, what is SQL? The keyword or the short form SQL, or the abbreviation SQL, means structured query language, right? And it's a standard relational database language specifically designed for managing and manipulating relational databases, of course. Right. Now, it is a database language, not a programming language. For programming languages, we probably can use them to develop something or to build something that can be used. But for database, but for a query language or a database language, they cannot be used, or it cannot be used to develop a software or so, right? And it's just like when you're in a city, or for every door, there's a key, right? For every country, there's a language, right? So for databases, for every relational database, there is a language that it understands. Just one. Now, when dealing with databases, this is something that is widely known by developers. The basic thing you can do with a database is to perform something we call the CRUD operation. That means you should be able to create, for example, user should be able to register, you should be able to create a new user, you should be able to find out what is in your database. That means read what is kept in your database. You should be able to update a particular record. For example, let's stick to the user example. So let's say a user registers. We should be able to see all the users who have registered. Once we see all the users who are registered, we should be able to say, for example, a user registered with a particular email and they would like to change it, or they forgot their password, they would like to create a new password, which is basically, we don't have to delete the entire record to do that. You just have to update what was there before. That means replace what was there before with another password or something else, right? And we should be able to delete it, as users should be able to delete their account, right? These are basic things when it comes to database operations. And SQL helps us to perform all of this, right? We can manage this structure as well, and we can also control access to data. Okay, so simply put, all of those in grammar or English, it's just that it's a language that is used to interact with databases. It allows you to store data, retrieve data, update data, and delete data. All right. So simple analogy: if a database is a warehouse, right? SQL is how you access or change or organize what is inside. It's simple. It's used in relational database management systems like MySQL, PostgreSQL, Microsoft SQL Studio, and lots more, right? Now, the next question. Fine. Now I know what SQL is. Why should I learn it? Well, if you're a data analyst, you should really learn SQL. As much as the usage of SQL strongly depends on where you work, the company you work, that means the company organization where you are employed, and the kind of structure they have in there and the kind of tools they use, right? However, there's a core skill that data analysts should have, right? So just glance through the few things we have here. Data extraction helps you retrieve um, specific data from like data sets quickly and efficiently. That can help you answer data related questions. We also have data transformation. You can clean, organize, and format data. You can filter it, you can group it, you can aggregate it, all to make you ready for analysis. You can handle large data sets. It handles it without stress. Uh, like someone will say, it is Excel on steroids. Okay, right. So Excel can't do much. But SQL can do way, way, way higher. Okay, and it's essential for BI tools majorly, data science and BI tools, right? Visualization tools like Tableau and Power BI. They are easily um, connectable. If there's a word like connectable, or we can easily connect them to those visualization tools. Okay. All right. It is widely used in the industry as well. SQL is used for handling data, making it a core skill for data analyst role. All right. Simply put, this is just a breakdown. Just take a few seconds to glance through. Okay. Let's move on to the next thing. So example. Now look at the sample of a query. What getting or saying, I want to see the name and the salary from the employees table where the salary is greater than 800,000. Oh, how come I still have all this SQL there? So what does this answer? It answers those who are high earners. That's just what that's see. It's not just writing the query alone, it's to understand what the query is doing, right? So that way we can see the high earners. Depends on the range of the salary in a way. Okay, so types of databases quickly, since we have established the fact that SQL is a database language, right? So database is an organized collection. Let me put it in simple English. It is a structured collection of data, rows and columns. If you're familiar with Excel, you have rows and you have columns. The same thing with databases, right? It's as simple as that. Of course, you still see it practically. We'll use it, we'll write queries, you'll see how it works. Okay, but just keep in mind that it is a structured, it's stored data in a structured way, in rows and in columns. Okay. Now we have two types, not just two only, in all honesty, but basically or fundamentally or foundationally. Let's keep things simple and at the barest minimum, just core things you need to know. We have relational databases. We also have SQL, which we also call non-relational databases. Okay, and as you can see, relational databases stores data in tables, simple rows and columns in tables, and these are examples of them. While NoSQL stores in key value pair, document formats, different things like that. So more flexible structure, not rigid or fixed like tables. Of course, they're very good. Example is MongoDB. Okay, so these are just two core ones that you should know. Of course, you can make research and read more, but I would not really advise that. One thing is, as you advance in your career, you get to know some of these things as you go, right? I'm just trying to put them in your head right now. Rarely will come in an interview question, right? Okay, so not something to really bother about, rarely, quote and unquote. Okay, so basic concepts in SQL. What are some key concepts in SQL that we should know? Okay, the first thing is tables, right? We already established the fact that SQL work with tables. Now let me bring a picture to you. How does SQL relate to relational database, and how does it concern us as data analysts, and how does it help in the real world? Now, think of it this way. Let's say a franchise or a restaurant, a supermarket, whatever it is, okay? And of course, we have quite a number of people who go in there, make purchases daily, and it is not reasonable to have all the details of a customer and what they bought on a single table, right? Oh, so this person came today, bought this, and they will have what they bought. The same person comes tomorrow, on the same table will duplicate all the entire record, the location. It's just too much redundancy, right? And we don't want that. What about we keep things separate, right? So we can decide to keep things separate, because obviously, if we read further, we'll see that it stores data about an entity, just one entity. So that's the best way of storing data, okay? So since this is how real world businesses store data, and they're only able to do this because they use a relational database. Why? Why relational? If we have a table that holds the customer data, and we have one that holds the product, and we have one that holds sales. Now, when a customer makes a purchase, we should be able to link it. Since we don't want to duplicate the record, we should have a way to link the customer who bought the customer on the customer table and the purchase on the sales table, so we don't have ghost purchases, right? So it is a relational database that allows us to be able to establish relationships between tables. Relationship singular between tables, right? Hence the use of relational database, and hence the use of SQL. All right, since that picture is clear, so we have tables. What are key concepts to know? We have tables, right? And they're organized rows and columns, and they store data about one entity: students, teachers, courses, etc. Now we have rows, which could also mean record, right? Horizontal components that represent a single complete entry or set of related data across columns. So let's just take a quick look at this. This is row 1, where we have John 1 and 22, right? So since this is row 1, this is also one person's record. The ID of John is this. The age of John is this. So this is a record, right? And it's also a row. Simple. Why fields are vertical ones, right? So this is student ID, an entire column. This is a column. This is another column. This is another column. All right. Now, that being said, what are these sub-languages, or you can call them commands? Then let's just call them the 5 SQL sub languages, and they're important for us to know. The first one is DDL, and DDL is Data Definition Language. So the first D is data, data, data. This is transaction at this point, okay? So data definition language, that's the first D, data and definition language. And what is the purpose? What do? They define and manage the database structure. When we talk about the structure, we're talking about we're creating a database, we're creating a table, we're creating columns. That's still the structure. We have not put in anything in there. Or later, even when we put in some stuffs in there, let's say records, we create users. But then we want to say, for example, a column was titled email address before, but we felt that name is too long. We want to change it to email. So from email address to email, we are still messing. Let me use the word messing first with the structure of the table. But let's say we had 10 columns. We felt like, okay, one of these columns are not necessary. We'll not take it out, right? We are restructuring the table. So anything that has to do with the structure of the table, right? We use DDL. And the three main commands are the create, alter, and drop. I call them CAD. Create to create tables, alter to change something, and drop to remove something, to take something out. And of course, truncate works with the records. All right, that's that about that. Then we have DML, data manipulation language. Now, for data manipulation language, this is how you put in things into your table, actual records now, and you can also change what you've put inside your table, and you can also take it out completely, right? And we have the IUD, the insert, the update, and the delete, okay? And we also have DQL, which is the major one. Now, one thing you understand is when you run any query without this guy, all you will get is either a success message or an error message, okay? You only get a success message or an error message. Good. So whenever you run select, that is when you get results from your database. So please take note of that, very important. And of course it has siblings, but the major command, it's just like in the work area, when you're queried, what do? You respond to the query. So if you want to find out what is going on in our database, in our table, we query the table. We ask questions. We say, show me this, show me that. And that's what the select does for us. And we have this here, data control language, which is used to manage access and permissions to databases. So that means we can grant access and we can also revoke access. So these are the major commands. And we also have TCL, which is transaction control language, where we can manage transactions to ensure data safety, okay? And the keywords are commit, rollback, and save points. So majorly our focus will be on the first three, okay? Just to keep things simple and basic. All right, now that I've seen the sub languages, let's look at the SQL constraints, okay? Now, what are constraints? Constraints are just from the word constraint, the English word mean you're restricting something, right? Or you're imposing certain rules to be able to achieve something, right? Some certain thing. For example, let's say there's going to be a curfew, nobody should move by 7. You get, could be for security reasons, so that we can achieve that. We impose um, the rules or restrictions, right? But in this case, in the case of data, their rules apply to tables to enforce data integrity and consistency, okay? Now, some common SQL constraints include not null. It means that a column cannot be empty. They cannot have null value. Null means nothing, empty, null. Okay. Now, consider them as when you want to register on a website and you missed out on a field. You didn't remember to put anything. And you're trying to submit and they tell you that this field is required. Exactly. That is what not null does. You're saying you cannot leave this empty. You have to put something there, whatever it is at all. Okay. And this is a structure or a syntax of writing not null. To create a table, we'll have the keyword create table. Then we'll have employees or whatever table name you want. So this will be our table name. Then we can have the column name, the data type, and optionally a constraint. Again, the column name, the data type, and optionally a constraint. Okay, so this is how we can use not null. So I was saying ID cannot be empty, name cannot be empty, right? So we don't have someone registered on our account or on our software or on our application without a name, right? The next one is unique. Ensures all value in a column are distinct. It's the way you want to register with an email and they tell you this email is already in use. That means two people cannot be tied to a single email address. Now think of it this way, that the same account number you have, your account number with which you credited or debited, someone else uses exactly the same account number, the same bank. What do you think is going to happen? Right? You can start to think of that. So it has to be unique. It has to be unique. All right. So that means two people cannot have the same. The next one is primary key. Primary key combines the first two that we have seen, and it ensures each row in a table has a unique identifier. It ensures each row in a table has what? A unique identifier. That means you can identify one row uniquely. Think of it this way. There are two people with the same first name, last name, and middle name. How can you distinguish? Probably the ID. Okay. And that's why systems uses IDs. When I say systems, for example, school system, they have IDs, work system, they have IDs, transportation systems, they have IDs, and so on and so forth like that. So now we have foreign key. Okay. Now, so I will take time to just quickly run over primary key again. The primary key identifies a row uniquely on a table. So for example, on every entity table, you have a primary key, or you should have a primary key, at least one, basically one, right? So on a customer table, for example, you should have customer ID. On a student table, you should have student ID. On staff table, you should have staff ID. Okay. Now, foreign key is how we establish relationship between two tables by referencing a column in another table. Remember when I started the example of how that businesses use relational database, and this is due to the fact that we can establish relationship between two tables such that when a customer make a purchase, even though the transaction is logged on another table, we can still reference or link or tie the customer to the purchase, right? So it is a foreign key that helps us establish this relationship. And how do we do it? Now for primary key, we just have to add primary key as a constraint. For unique, we just type unique. For not null, we type not null. So for primary key, we type primary key. And for foreign key, we type the column first. So we're saying the customer ID will be an integer. And then of course, okay, I think there's an error right there. So we're supposed to have foreign key, then we'll pass in this. Don't worry, we'll still see it practically. Okay, we'll still see it practically. That was omission in typing. And we should have, okay, the customer ID, then the data type, then we'll say foreign key, then in brackets, we'll pass in this column. So it is this column now that will reference the ID on the customer table, okay? Like I said, you see practically, you understand what I'm saying very well. Okay, so we also have check, which is another constraint, and it ensures a specific value or a specific column satisfies a condition. So for example, you don't want non-adults to use your application. You can have a check and you say there must be at least 18, right? So if they try to impute any age lesser than 18, tells them, maybe they can see an error message and say, oh, sorry, it must be at least 18. Okay, so that is what check does. It gives you the flexibility of adding a specific condition to a column. It could be length or. Right, the next one we have is defaults. Okay, and for defaults, you can assign a value if the user or before the user provides one. See, like simple example is just like, say you register on an application and you decide not to provide your name. What would they do? They can create a username for you by default. You just use user 0, 1, 2, then one long string like that. And you might not necessarily like it, okay? But the certain thing, one cool thing is that you can change it later, okay? You can either change it, or another example could be WhatsApp. When you create a WhatsApp account and you don't upload a picture, you get an avatar by default. So those are default value, okay? And this is how you write the query for them. That is how you write the query for them. Okay, all right. This is how you add the query for them. Just add default and you put the value you want to pass in. All right, now let's understand data models. Since we have understood the sub languages, you understand constraints. Now let's understand data models. That's relationships. We established the fact that primary key and foreign key are used to establish relationship between two tables, right? So what are the kind of relationships that we can have? We have a one-to-one, which means one record related to one record. We have one-to-many, which is the most common one. For example, one customer probably has many others, right? And then we have many-to-many, which is like different students, one student, many courses. So many students, many courses. So you get the idea. Now, a foreign key, the same way you're in a country and you're a citizen, right? But when you're outside that country, you become a foreigner, okay? So if, for example, customer ID is on customer table, it is a primary key. But if customer ID appears on sales table or transaction table or orders table, it is a foreign key. And that's the idea. So we can have one-to-one, one-to-many, many-to-many relationships established, okay? And what is cascading referential integrity? This is how we make sure things are updated. There's synchronization across our tables, okay? So for example, you have a user who has made some orders, some purchases, or maybe it's just an account, maybe a social media account and all of that. And the user decides to delete their account. If the user decides to delete their account and there is a cascading effect on it, everything they have ever done, all the activities will be deleted along with the account. And that's why you notice that whenever you're trying to delete an account, some applications will tell you, you will lose all your data, you'll not be able to recover them, we won't, like, everything is gone. It will be as if you're starting from scratch. We don't know you anymore. There's no record of you in the system. However, some will just say, are you sure you want to delete your account? And whenever you try to open the account again with the same email address, you find out that, oh, you still have some details of what you've done before. Some of your activities were kept because there was no cascading referential integrity. Now let's break the words down. Cascading. In simple English, it sounds like you stacking things, right? Simple English. Reference, from the word referential, reference. Okay, that will be, oh, I'm saying this is this. From this place, I'm pointing to something else, right? I'm pointing to something else. And integrity means, oh, this is true, right? You can trust this. This is true. It's true. You can trust it. What other English can we use for it? I'm not sure. So it's just English anyway. All right. So, cascading referential integrity will now mean when I update, for example, if a user if a user changes his or her name or their name, it updates across all connected tables. The same thing if they delete, it deletes across all tables. That's why if you've worked with database for a while, you notice that if you're trying to delete a table, right, with foreign keys, it will tell you that, oh, wait, this is depending on some, or you're trying to delete a table with primary key where the foreign keys have already been established, to tell you that, oh, wait, what you're trying to do, it's not going to work. So you have to force it to say, I know what I'm doing, and then you delete it. Don't worry, we'll still see all of this practically. If you have any questions, do not to ask your questions, they will all be answered. Then we look at the concept of normalization, which is something very key and important. This is how we avoid redundancy in data. Okay, because we're using relational database does not necessarily mean, or does not automatically mean we will have normalized data. Okay, so normalization in SQL is the process of organizing a relational database to minimize redundancy and improve data integrity. Okay, it involves decomposing large complex tables into smaller ones, related ones, of course. Now let's just jump into the examples. We have different forms, and we'll just be looking at the first two because these are the most common ones I would likely work with. So we have the first normal form. And what are the rules? Multiple values should not be or cannot be in one column, like this. Each field must be atomic, right? Definition back then means atom is the smallest unit of. All right, you get what I'm saying. So this is wrong, but this is right. So this has been done again with math and then with English. This is the first normal form. Okay, see the same thing here. Now we corrected it right down. All right, now let's see second normal form. It means, of course, it must already be in one normal form. Then there is no partial dependency. That is, every non-key column must depend on a primary key. Now let's look at this. Look at this now. This is student ID. This is course ID. This is student name. This is wrong. This column has this, right? So we are not supposed to have this because this can get us this. Now let's just look at the problem so you understand it in more English way. Student name depends only on student ID. So we are not supposed to have it here again. Course name depends on course ID. Okay. So what is the right way? We should extract the table. We should have a student table, the person's ID and the name. So it does not appear on the course table. Then we have the course and the course name. And finally, we have an enrollment table where we can see the student ID and the course ID. So if we want to see the student name, we can use this because this will be a foreign key now, right? Because student ID on an enrollment table is a foreign key, right? So that is the second normal form, and that is the major thing we'll probably see, okay? Now, the next thing we want to understand or learn is data types. Data types in SQL. Of course, we have four major data types, which is text, number, Boolean, and date time. However, as we move from software to software or programming language to programming language, as we move from one tool to another, what we call them might slightly change. Okay, so for example, the number types of data in SQL, you can use integer. You can either type it in full or type it in short form. Integer, you can also have small int or big int. We have decimal, where 10 is precision, 2 is scale. 10 means 10 digits. 2 means 2 decimal place. So this is an example. Then we have float. Okay. Now the next thing is character. We have the character, this character, then n, which is a fixed length. We have variable character, which has a variable length, and we have text, which is unlimited. Also, we have date/time. See the date, this is how it stores date format, year, month, and day. Then we have time, hours, minutes, and seconds. Then we have timestamp that combines both of them. Boolean. Boolean is basically true or false. And these are advanced types. It's JSON, JSONB, UUID, array, and all the like. So you can exclude this in your head or your mind or from your brain, okay? Now, what are the basic operations? So that we don't get overwhelmed, of course, so it's quite a lot. I'll stop this here so we can split this up and have it in another video. So do not forget we stopped at this point, data types. Now that we understand data types, let's see how to get them used. And once we see how to get them used, we'll now look at the best practices, okay? So see you in the next video. Peace.